Hi everybody, and welcome to today's live video. Today we're going to be talking about osmosis, diffusion, and solubility. First, I'd like to thank our sponsors, Promo Science and Actua, for making all this possible. So let's start with osmosis. So osmosis is the flow of a substance through a semi-permeable membrane or barrier from an area of high concentration to an area of low concentration. Now, this is an important biological process for cells in our bodies and in plants. As you can see here in the picture beside me, we have red blood cells and plant cells. So looking at the red blood cells, the first picture there is red blood cells that are hypertonic, which means they have a low concentration inside them, and so the water inside the red blood cells is pumped out into the blood, leaving them shriveled up. The middle picture is isotonic, which means the concentration inside and outside the cells are the same. So they just have water going in and out, and they're normal sized. And the last picture of the red blood cells is hypotonic, which means they have a high concentration inside. So they have water flowing inside the cells, and they thus inflate. And the same things can happen with plant cells. So you can see the first one, isotonic, and it doesn't. It has a concentration equal to outside of its walls, so it remains in equilibrium. So this is an important process for moving salt through red blood cells, through our blood, and all kinds of different chemicals. So to show this in an experiment, we put some gummy bears in some different solutions. So here's a little time lapse of that. So this takes several hours to do. You can see the far left is distilled water, the middle tap water, and the last one is our salt water. And the beaker behind the salt water, you can see the liquid turns red because all of the salt is making the gummy bear force its water into the solution. So here's some more pictures of them. And as you can see, the gummy bears that were in the distilled water are much larger than the gummy bears in the salt water. So next up is diffusion. So diffusion is a similar process to osmosis, except it involves no semi-permeable membrane. So as you can see in the picture beside me, we have food coloring that goes into water, and it spreads out through the entire beaker of water so that the concentration is equal in all parts. So we can show this with Skittles. So I'm just going to flip over to Taylor here, and you can see the Skittles in water. So when we add the water to the Skittles, so as the Skittles set in the water, the dye will start to come off the Skittles, and we'll see what happens there. So again, diffusion isn't an instant process. It happens over time. So as you can see now, the dye is starting to come off the Skittles. So the dye is highly concentrated around the Skittles. So it wants to move to an area of low concentration, like the middle of the plate. As you can see, it's happening now, and it happens very slowly. So let's move on to solubility. So solubility is the ability for a substance to dissolve into another substance. So solutions, as we call them, have two parts, a solute and a solvent. The solvent is what does the dissolving, and the solute is what is dissolved. So if for a few other of our demonstrations today, sugar will be our solute and water will be our solvent. Solutions where water is the solvent are known as aqueous solutions. But water isn't always a solvent. Sometimes water can be the solute. Like when the air is humid, like on a hot day, the air is the solvent and water is the solute. The water is dissolved in the air. So we have a rule when talking about solubility, and that rule is like dissolves like. So we talk about polar and non-polar molecules. So water, as you can see here, H2O, is a polar molecule, which means that electrons in the molecule are not evenly spread out. There's more electrons around the oxygen atom, which means the oxygen atom has a negative charge, and the hydrogen atoms will have positive charges. And that goes for sugar as well. It has a lot of OH groups, as you can see, and it makes sugar a polar molecule, which means that sugar will dissolve in water. Other nonpolar molecules like toluene and methane have more spread out evenly electrons, so they don't have charges or don't form charges as easily. So right now I have a beaker with oil. So let's see here. And I have a beaker with just some room temperature water. So I have some sugar here and it's dyed blue, so you can see it very easily. So what I'm going to do is I'm just going to take a spoonful of that sugar and we're going to add it to the oil and we're going to add it to the water. So what do you think is going to happen? So obviously we already know that sugar can dissolve in water. So we'll add the sugar there. So what do you think is going to happen when we add sugar to the oil? Give this a little swirl. You can kind of see some of the sugar on the bottom of the beaker here. So I'm just going to add some of the sugar here to the oil. And we'll see that when I put the sugar in the oil, it kind of just clumps up at the bottom here. And that's because the oil is nonpolar, unlike the sugar. So the sugar wants to stick to itself and not dissolve in the oil, unlike in the water, where it spreads out by it and dissolves. So that's how solutions are formed and how we can dissolve substances. But how can we change the rate at which these substances dissolve? Well, certain things like temperature, surface area, and agitation will affect how quickly a solute dissolves in a solvent. So first up is agitation. So you'll see here that I have a hot plate, and I'm not actually going to turn it on, but I will have a stir bar in here. So you can see there's a little magnetic stir bar in here, and this beaker is just water without a stir bar. So I'll turn it on, and we'll start stirring this mixture. So first we'll add the sugar to the regular beaker, and then we're going to add a spoonful to the stir bar. You can see without stirring, much like the last demonstration with the oil and water, that the Sugar kind of stays at the bottom, and the water has to do all the work. But already, in just the time it took to do that, there's barely any sugar left visible in this beaker. So the stirring greatly increases the rate at which the sugar is dissolved in the water. So speaking of hot plates, next up we have some beaker here with warm water. You can see some of the steam on the side of that. And a beaker of cold water. So which beaker is going to dissolve faster? Let's hear your ideas. And if anyone has any questions during the thing, don't hesitate to ask, and I'll answer them to the best of my abilities. So I'll just add some sugar to the cold water here. And add sugar to the warm water. And I'll give both of them just a little stir. And then we'll take a really close look here. So this is the beaker with the cool water. And you can see that there's quite a bit of sugar still left on the bottom here. There's quite a big clump of it. And in the warm water, you can see there's a much smaller spot of sugar on here. So the warm water dissolves the sugar much faster than the cold water. So finally, we have two beakers here, water, both the same temperature. And this time, instead of a spoonful of sugar, I'm going to add sugar cubes. As you can see, they're dyed blue here, so you can see them better as well. But before I add one of these cubes, I'm going to crush one of them. So when we crush a sugar cube, we increase its surface area, and those little sugar crystals are no longer trapped inside the cube, but are free to dissolve in the water. So the water doesn't have to dissolve all the other molecules around them. So we add them in, and you can see quickly that a lot of the sugar from the crushed cube has already been dissolved in the water, as you can see by the blue color. But the one with the whole cube in it is still quite clear and hasn't dissolved much yet. So that's just a few ways that we can increase the rate of dissolution, and that'll work for any substance, not just sugar and water. So just a quick recap, because we covered a lot of topics today. So osmosis is the flow of particles through a semi-permeable membrane in order to reach equilibrium. Diffusion is also the flow of the substance to reach equilibrium, but it doesn't involve a semi-permeable membrane. Solubility is the ability for a substance to dissolve in something else, and the rate of reaction can be affected by temperature, surface area, and agitation or stirring. So that concludes today's presentation. Is there any ideas or questions? While we're doing that, I also still have the oil and water here. So just to further illustrate, and I find that this kind of looks pretty cool. When I pour the oil and water together, we can see the sugar is all clumped together because of the oil, and it doesn't want to stay with the oil. It wants to sink to the bottom into the water. And you can see the oil coming up from the bottom. It's pretty cool. And that also further illustrates that oil and water have different polarities, because they don't want to dissolve in each other. They just sit on top of each other. Just wait another few minutes for questions. So we have a question here. Which is the solvent solution with water and water? Well, water doesn't dissolve in itself. So it really just kind of sits on top of itself. One cool thing, which we talked about in a past video, is surface tension. So if we have water and I was to fill one of these beakers past the top, the water surface tension will keep the water just a little bit over on top, and it won't overflow right away. But water can't dissolve in itself. It's just a beaker of water. Oh, oil. Okay. Well, yeah, I just answered that one. The last one. They don't dissolve in each other at all. A great question, though. So if there's no more questions, that's going to do it for us today. Make sure you tune in next week for our live streams every Tuesday, Wednesday, and Thursday. And have a great day, everyone.